All right, hello, this is Mrs. Short, and I'm going to go over the answers to this review sheet for our first test here. So, this first question asks you to draw the absolute value graph on the coordinate system on the left. And so remember, the absolute value graph starts at the origin. It has a V shape to it, and let's go ahead and do that. So, it's going to start at the origin with the dot, and it goes on the right side up 1 over 1, up 1 over 1. And so basically you could take it to the corner right there. All right, and then other side goes up 1 and left 1, up 1 and left 1. So the right side has a positive slope, the left side has a negative slope to it. All right, and 1 unless it's changed. All right, so we have this new function over here. We have to write down all the transformations that are basically from this blue graph to this graph you see right here. All right, so first of all, I see that the graph has been moved to the right and up to get to this new vertex. So the new vertex is at 1, 3. So it's been moved to the right 1 and up 3. So I'll jot those down. So right 1 and up 3. It hasn't been reflected, but I do notice something different about the slope. You notice how the slope right here is 1 over 1. Well, this slope, if I go from the center, it goes up 1 over 2, up 1 over 2, or up 1, back 2, up 1, back 2. So the slopes here are plus and minus 1/2. So this thing has been shrunk. So it has a shrink. So that new slope belongs right in front of the absolute value bars. So I'm going to put some absolute value bars. I'm going to put a 1/2 in front of there. That's where the new slope goes. And then I have, since I'm moving 1 to the right, I will put x minus 1 inside. And then let's see, up 3, so plus 3. So remember, you could always go to Desmos if you want to check some of these answers or check on a graph. Let me just find my Desmos here. So that graph was 1/2 x minus 1 plus 3. So you could always type in, y equals, and instead of 1/2, well, I could just do 1 divided by 2. Sorry, I was going to put a 0.5. Absolute value bars, so there they are on the bottom. And let's see, x, we wanted minus 1. And then let's jump out of those, and oops, I need to go ahead and put an absolute value bar again, and then plus 3. So just confirm that that's what the graph looks like that we were trying to make, and it does. All right, so this next one, given the graph at the right, determine the equation of the function. So basically what we just did, this one went left 4 and up 2. So that vertex right there, left 4, negative 4, and up 2. Those are going to be the numbers involved in like this part of my problem. So here we go. So absolute value, there's no shrink or stretch because the slope is still 1 over 1 on both sides. So left 4 would mean I go x plus 4. And then up 2 means I need a plus 2 on the outside. Remember, inside moves you side to side, outside moves you up or down. The numbers on the inside are kind of opposite of what you might think, but the numbers on the outside pretty much match what you have. All right, interval notation, write the domain. So remember, the domain is the width of your graph, or the x values that it passes through. All right, so it might be a good idea to go ahead and label some other points right here. So this is on the right side, so x is going to infinity because it's an arrow there, and the graph is going up. This arrow over here, the end of the graph, is going left, so that's my x value, because my x-axis, when it goes far to the right, is positive infinity, my y-axis is negative infinity, and this arrow, the y value, is going up. So you can do it this way, and then you think to yourself, the domain. So these are the 3 important points on my graph, right here, right here, and right here. So the smallest x value that I see out of all these 3 things is negative infinity, and the largest one is positive infinity. So there's my answer. Or I just say to myself, what's the width of my graph? Well, this side of the graph goes to the right forever, this goes left forever, so I want to say all real numbers. So the way that you write all real numbers with interval notation is negative infinity to infinity. Now the range of the graph, so the range of the picture, this graph goes down to, let's see, this level, and then it just goes up forever. Okay, so right there, that would cover the range of my picture. It doesn't go lower than 2, and it includes 2, and then it goes up forever. So again, the smallest y value is 2, the largest y value in those points is infinity. So 2 comma infinity, parentheses on infinity always, bracket on the 2 because it's touching 2. All right, number 3, domain and range. So in this picture again, my domain is my width of my graph going right and left. My range is my height of my graph. So if I think about it, my width of my graph, the width of my graph, this graph opens up forever. So the width of this graph is everywhere. I know that the graph seems to stop right here and right here, but as those things go down, this one keeps going to the right, and then this one keeps going to the left. I've exaggerated a little bit, but eventually it's going to open up every direction. It's going to go every direction, right and left, or every number. So my domain is, let's see, interval notation, negative infinity to infinity. But my range, on the other hand, is not that. My range only goes up to this level right there. And then, so that's 1. My highlighting is a little bit off right there, but you see it's going up to a height of 1. That's the highest, and then it just comes down. So that section right there, the highest it goes is 1, and then it keeps going down to negative infinity. So when I write that, I put the smaller thing first, and then the bigger thing second. It's touching 1, so I put a bracket, and then parentheses. All right, here the domain and range are kind of more clear. So you can easily get this by labeling some points. This is 4 and negative 3. This guy up here is 2 and 1. All right, so my x's go from 2 to 4. My 2 is not included, but my 4 is included. So 2 comma 4, include the 4, not the 2. And my y values are 1 and negative 3. But remember, I got to put the smaller thing first. So negative 3 to 1. 1 is not included, but negative 3 is. So remember, the domain is the width of your graph. The range is the height of your graph. And so this is domain, this is range. And so that's what we were just kind of doing right here. All right, next page. So describe in words the transformations for g of x equals negative of x plus 5, absolute value, minus 2, from this parent function. All right, so I have 3 things that happened. This negative right here causes the graph to do a reflection. So it causes your graph to like flip over, you could say, kind of like this guy down here, okay? But flip is not like the proper term, we say reflection. All right, this plus 5 causes you to go left 5, and the minus 2 causes you to go down 2. And again, you can inspect this on Desmos. So I could, in here, go ahead and graph it, y equals, let's see, negative, right? Absolute value, x, and I forgot what the problem was. All right, x plus 5 minus 2. X, put your plus 5, and you see that, oopsie, nope, that's supposed to be inside. And my absolute value bars, and then minus 2, I think it was. And so there it is. So that is compared to the graph of the regular absolute value function, which is just y equals absolute value of x. So if I put that and I kind of ask myself, well, how did it change? Well, it moved left 5, down 2, and it's reflected. Okay. All right. So factor number 5 completely. So number 5, I have to, first of all, anytime I factor, I look for the GCF. Remember the letters GCF means greatest common factor. All right, so 9 and 15. The greatest number that they both divides into 9 and 15 is 3. So I'm going to pull out a 3. X squared and x. The greatest thing they have in common is an x. So then I write what's left. Now if you want to, you can like cheat a little bit and ask yourself, okay, I'm going to divide this by 3x. That's really what we're doing right here, is we're dividing out this 3x that we're bringing out front. So 9 divided by 3 leaves me a 3, and I have 1x left for this division right here. And then 15x divided by 3x makes me 5, so I put plus 5. And one thing I can do to check, I can always multiply this out in my mind. Yeah, that's 9x squared. And this one is 15x, so I know that I have what I started with. All right, for number 6. On number 6, I want to label these points here to help myself out. So I have my vertex here at 3, 0. And then I have this arrow on the left. So remember, this graph, as it goes to the left, that's negative infinity, the graph is coming down. Okay, so I'm going to put an xy value here. That would be negative infinity, comma, negative infinity, because this is telling me the x and my y of that arrow. It's going left and down. Okay, on the right here, the graph is going to the right. So remember, when you go far to the right, that's positive infinity. So this is going to the right, but it's also going down like the other side. Okay. All right, so this is going to tell me all my answers once I get those correct, my domain. So look at my domain. Let's see. Look at all these x values that are kind of containing my graph. The smallest is negative infinity. The biggest is positive infinity. So negative infinity to positive infinity. The range. If I look at all these y values, these two match, but the other one is 0. So this graph is, the highest it goes is 0, the lowest it goes is negative infinity. So I'll put negative infinity, 0 with a bracket because it's touching 0. Increasing. All right, so it's important to recognize increasing. Increasing means that you have a positive slope. So a line with a positive slope looks like this, like in Algebra 1. This has a positive slope, so we call that increasing. Right? If something has a negative slope, we call that decreasing. So remember, this is what we're doing here is we're reading the slope from left to right. So as you approach a graph, when you read a graph, you come in from the left-hand side, and you're like, oh, here I'm hitting the graph. I keep going, it goes up, and then it goes down. So my graph rises and then falls. We are not looking at these arrows right here. I am just looking at the graph from left to right. It's rising, so that would be an increasing area. Then it's falling, and that would be a decreasing area. Okay? All right. So increasing, decreasing. Now, where that section breaks, what happens here, the reason it increases on the left and decreases on the right there, it changes doing that. It's increasing all the way to this area. So this whole section of my graph is increasing. So what I'm going to do is name that section. That section goes to from negative infinity, and look at where it stops. It stops right here at 3. Right here, this line is at 3. So that's my increasing section. And then the other part, the next piece over here, this whole area is all decreasing. So that section starts at 3, and it just goes on forever. It goes off to positive infinity. So there's my answer. The increasing interval is negative infinity to 3, and we always put parentheses because at 3 you're not doing anything. You're just finished increasing and you're waiting to go back down. All right, and then decrease would be 3 to infinity. All right, x-intercept. So there's only one x-intercept here because the graph is flipped over and it's touching at 3, 0. So I'll just say 3, 0. It's a point. The y-intercept, I see that happening right down here at -6. So also an ordered pair, 0, -6. Now here's my end behavior. So my end behavior is going to be basically me looking at what I wrote on the ends of the graph. So when x is positive infinity, oh, so that means when x is going this way. So when you're on the right side of the graph, so you're looking right here, the right side of the graph is going down, 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 and there it is. Look, there's your x, and here is the y value that I'm supposed to answer. So negative infinity. All right, now, frankly, both sides of these graphs are going down, so I don't really have that big of a choice here, but let's just take a look. This one says when x is negative infinity. Well, there it is. X is negative infinity, and so is y at that point. All right, and the equation, let's see. Let me check out my slope. If I look at the slope here, it's down 2 over 1, down 2 over 1, or it's up 2 over 1, so my slope is 2. So I have y equals, oh, I already have y equals. So y equals, I need a 2. That 2 needs to be negative because it's reflected. And this thing has been moved to the right 3 places. So I'm going to say x minus 3, and it has not been moved up or down from the center. So basically what happened, it was at the center, it moved right 3, it flipped over, and that is the 3 and the negative, and then the 2 made the slope different. All right, number 7. On number 7, I have to plug -2 into here. So I'm going to set up a little framework. So g of -2. -3 is there, something squared, minus 6, something, plus 10. All right, so I'm going to put a -2 in here. Now you can work this out, or I'm going to show you in a minute. You can go to Desmos and type it in. So I have -3 times -2 squared is +4. The next one, 2 negatives make a +12, and then plus 10. So I have negative 12 plus 10. So the 12s cancel, and I got 10. All right, so on Desmos, let's see, negative 3, 6, and 10. And I'm plugging in a negative 2. All right. I can also make a new line, and I can just start typing a question. So negative 3, parentheses, negative 2, parentheses squared. I forgot what it was, I'm sorry. Minus 6x plus 10. So let's see, minus 6, put another negative 2, 6x, and then plus 10, and there's the same answer. It just spits out the answer for you. All right, and let me do another one. Let me show you another little thing while we're here. Let's say I had to evaluate something, a whole different problem, but let's say I had 3, and then I was trying to multiply it by, I don't know, 4/5. All right, so let me just to point something out to you. Now, this decimal right here, 2.4, it's a nice pretty decimal. But in case you wanted that as a fraction, notice this little fraction button up here. You can turn something into a fraction and then back away from a fraction. Fraction, decimal, fraction, decimal, okay? In case you ever need a fraction. Because if you are doing math spaces and you want to get a fraction, that's what you're going to have to do. It's not going to take a decimal that's repeating. Like if I was getting something like, 2.3333333, it wouldn't like that. You'd need a fraction. All right. So that was just a little side note. Okay, number 8, I want the decreasing section. So first of all, you have to go back and remember a positive slope is increasing, a negative sloped thing is decreasing. So I'm looking for the part that looks like this. So that would be this side of my graph. So I'm going to shade that in. So the side of my graph that's decreasing goes all the way to that little point right there. So this side of my graph is decreasing, all right? And so this section that I've shaded in here lasts until 2, because that spot right there is 2, 3. So we're only using x values, and it just keeps going to the left. So that would be negative infinity. So this is the section. These numbers are noting the section that is decreasing. So I'm going to say decreasing interval is negative infinity to 2. Always put the small thing on the left, the big thing on the right for increasing and decreasing intervals, and also for domain and range. And I always use parentheses for increasing and decreasing. And that is it.